Hello class, today is going to be 62-3 and we're going to take a look at polynomial inequalities. And so today's objective, we're going to solve polynomial inequalities. Now when we solve a polynomial inequality, it's very similar to solving quadratic inequalities, which we've already gone over. Now remember that the goal is we need to find the zeros, and once we have the zeros, it's like we're sectioning our number line. And when we're sectioning number lines, we're trying to figure out where my graph is above or below the actual number line here. And so if my function is greater than 0, we know that it means it's positive. If my function is less than 0, then we know it's referring to negative numbers. And so that's something to just be aware of as we're moving forward. Now this first example here says f of x equals x squared minus 2x minus 8. Find my function being greater than or equal to 0. And so we need to find where it crosses that x-axis, and so we're finding the zeros of my function. Now because this first example is a basic example, it is a quadratic equation, I could easily factor this into x minus 4 and x plus 2, which means that my zeros are going to be positive 4 and negative 2. And so now placing those on the number line, because it does say equal to, I know it's going to be included values, so that's why my circles are going to be positive, or closed. And because it says greater than 0, I know it's going to be referring to positive numbers. So now I need to find the intervals that are going to be representing my positive and negative. And so we have to take values on our number line and we have to plug it into my function and determine is my number positive or negative. So I can plug in like negative 4, because there's a negative 4 over here. I can plug in a 0, and I can plug in like 5 or 6. Well, if I plug in negative 4, I get a negative number and a negative number. A negative is a positive. If I plug in 0, I'm going to get a negative number and a positive number, so negative positive is a negative. And then if I plug in like 5 or 6, I'm going to get a positive and a positive, and so I'm going to get a positive number here. Now going back to the beginning, we said what types of values we're looking for. Well, we're looking for positive values, and so these regions here are going to be my resulting answer. And so writing that in interval notation, that's going to be from negative infinity to negative 2, union from 4 all the way to positive infinity. And that's going to be my answer. So the first thing that I did here was I had to find the zeros. Now just know that the way that we find the zeros may be different, because in this case it was a quadratic equation. We know simple forms of factoring to be able to do that. As our polynomial becomes more complicated, we're going to have to use more complicated forms of factoring when we do this. And so I found the zeros. Step 2, I placed them on the number line. Now place them on the number line included value, because it's equal to, and remember, because it's greater than or equal to 0, I'm going to be looking for positive numbers. And so then I had to find the intervals of positive and negative values. And so to do that, I had to take values from this interval, and this interval, and test it into my function. And I determined that this was positive, negative, and positive. Because we were looking for positive values, that's why the positive regions represent my answer. And so my solution is going to be that represented answer here. Next example. So my polynomial is already factored, and so in this first step I want to find the zeros. And so finding the zeros, I know that my zeros are going to be negative 2, positive 3, and negative 5. So step 2, placing the zeros on a number line. And so placing them on a number line, I get negative 5, negative 2, and positive 3. Now because it's asking me to find values that are less than 0, first of all, these will be excluded values, so they're going to be open that way. And second of all, it's going to be asking us to find negative numbers, because negative numbers are values that are less than 0. And so now finding the intervals that represent positive and negative values, if I test in negative 6, I'm going to get a negative, positive, positive. So this is going to be a negative. If I plug in negative 3, I'm going to get a negative, positive, positive. So that's also going to be a negative. If I plug in like 0, I'm going to get a positive, positive, positive. If I plug in 4, that's also going to give me a positive. And so because it's asking for negative values, this values right here is going to be my solution. And so I just graphed in the solution what remains true with the inequality. And so my answer will be negative infinity to negative 5 union negative 5 to negative 2. Example number 3. Now, contrasting this with example number 2 here, this is a polynomial that has already been factored. But now with this next example, I have to actually factor this polynomial. And so to do that, I'm going to have to do my p's over q's. And so to do my p's over q's, my possible p's are going to be the numbers 1, 2, and 4. My possible q's are going to be the number 1. And so all the combinations are going to give me 1, 2, and 4. So those are going to be my p's over q's. Now I have to test them. I don't know what my zeros are yet. Those are just possible zeros. And so testing it, I got to try number 1. And so if I try 1, I get 1, 2, negative 3, negative 4, and 4. So bring it down, multiply, add, multiply, add, multiply, add, multiply, add. Now, I know that positive 1 works. So now these are going to be the coefficients of my remaining polynomial right here. Okay, these are my remaining coefficients right here. Now, having said that, though, I still need to try out 1. Because what if there's multiplicity? And if there's multiplicity, then 1 being a 0 would work again in that polynomial. And so I need to test 1 again. Now, to help organize it, I can write that 1 here. And so I can perform my division again. So, but we're going to ignore the remainder now. So bringing down the 1, multiplying, adding, multiplying, add, multiplying, add. And so once again, I know that 1 is going to work. Now writing out what I have 2 of these. So because I have 2 1s, I have x minus 1 squared. And then what I have left here, remainder constant x squared, this is going to give me x squared plus 4x plus 4. And so that will factor into x plus 2 times x plus 2. And I still have my x minus 1 squared. And so I have x minus 1 squared, x plus 2 squared. And so now, having said that, finding my zeros are going to be 1 and negative 2. So now step 2, placing my zeros on the number line, I have negative 2 and positive 1. So now I have open circle. Why? Because it's excluded values there. And it says greater than 0, so I'm looking for positive numbers. So we can keep that in mind. So now I need to find the intervals that represent positive and negative. So if I plug in, let's say like negative 3, well, I get a negative squared and a negative squared, so that's going to be positive. If I plug in 0, I get a positive, and if I plug in 2, I also get a positive. Because I'm going to square everything, and when you square a negative, it automatically comes out positive. And so that's going to be the regions here. So step 4, my solution is going to be those regions. So that's going to be here, here, and here. And so now my answer is going to be from negative infinity to negative 2, union from negative 2 to 1, union from 1 to positive infinity. Let's look at another example. Okay, so for this next example here, I'm just going to be focusing on the factoring part. If you guys wanted to see more on how to do the placing on the number line, the past examples would be really good at that. But I know that we need a little bit more practice on trying to find how to factor or how to find those zeros, and so I'm going to use this time to be able to do that. And so in this case, there is no p, right? For us to do p's over q's, there is no p. Typically when there's no p, that means that there's a greatest common factor that I can do. And so there's an x that I can factor out. And now this looks like difference of squares, and so I can say x times x plus 2 times x minus 2. And so having said that, my zeros now are going to be 0, negative 2, and positive 2. And so those would be the values that you'd put on your number line to then test and find what your answer is going to be. Now the next one, I'm going to do the same thing, finding my zeros. This time, I'm going to have to do p's over q's because I don't know how to factor that any other way, and I do have a constant. So my possible p's are going to be plus or minus 1, plus or minus 2, and plus or minus 4. my possible q's, that's just going to be plus or minus 1. So my p's over q's, that's going to be plus or minus 1, plus or minus 2, and plus or minus 4. So now finding the zeros, right? So I have to test these. So let's try positive 1. And so I'm going to try 1 into my polynomial. I'm writing out all the coefficients. And so bring it down, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. So now I have all those values that are going to be on the number line there. Well, I can check for multiplicity, so I'm going to test another one. So trying 1 again. Bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add. And so once again, I know that 1 worked again. Maybe it'll work one more time. I don't know. So let's bring down the 1, multiply, add, multiply, add, multiply. Look at that. It works again. So I have 3 of them. Now, having said that, I have 3 of these 1s as my 0. And now I'm left with x squared plus 4x plus 4. And so that'll factor into x plus 2 times x plus 2. And so I get this x minus 1 cubed, and then this x plus 2 squared as my answer. So now this does conclude our lesson. If you do have any other questions, please leave them in the comments.